The Liar Paradox. Once upon a time, a traveler arrived in a village where he met a man who said, "I am lying." The traveler paused. If the man is lying, then what he says must be false, which means he is telling the truth. But if he's telling the truth, then he must be lying, and round it goes. This is the Liar Paradox, a statement that cannot be consistently true or false. It's like a verbal black hole that traps logic itself. The Barber Paradox. In a quaint village, there's a barber who shaves everyone who does not shave themselves. One day, someone asked, "Does the barber shave himself? If he does, then he shouldn't, because he only shaves those who don't. But if he doesn't, then he must, because that's his rule." The town fell into confusion, realizing the question has no logical answer. This paradox exposes the limits of self-reference and logic. Achilles and the Tortoise. The great warrior, Achilles, challenged a tortoise to a race. Out of kindness, he let the tortoise start a few meters ahead. As Achilles runs to where the tortoise was, the tortoise crawls a little farther. Every time Achilles reaches where the tortoise was, the tortoise has moved ahead. Though Achilles is much faster, he never seems to catch up. Zeno used this paradox to argue that motion is an illusion, but it's not about speed. It's about how infinite steps can be packed into finite time. The ship of Theseus. Imagine a grand ship slowly having every single plank, nail, and sail replaced over time. Eventually, not a single original part remains. Is it still the same ship? Now imagine someone collects all the original parts and reassembles them. Which one is the true ship of Theseus? This paradox forces us to ask, what truly defines identity, material, memory, or continuity? The Grandfather Paradox. A young inventor creates a time machine. Curious and reckless, he travels to the past and accidentally prevents his grandfather from meeting his grandmother. That would mean the inventor was never born. So how did he go back in time at all? This is the Grandfather Paradox, which exposes the impossible loops that can arise with time travel. It's not just science fiction. It's a question of cause and effect. The Paradox of the Ravens. Hempel's Paradox. A philosopher once proposed, all ravens are black. So if you see a black raven, that supports the claim. But logically, so does seeing a green apple, because it's a non-black thing that is not a raven. Strange, right? This is Hempel's Paradox, which challenges how evidence works in logical statements. Sometimes the truth gets cloudy in the fog of reasoning. The Omnipotence Paradox. In a quiet monastery, a young monk asks, "Can an all-powerful being create a rock so heavy that even they cannot lift it? If yes, then they're not all-powerful, because they can't lift it. If no, then again, they can't do something." The paradox lies in the contradiction of omnipotence. Can limitless power have limits? The unexpected hanging paradox. A judge tells a prisoner, "You will be hanged next week, but it will be a surprise." The prisoner thinks, "If I'm not hanged by Friday, it must be Saturday, but then it won't be a surprise, so it can't be Saturday." Using this logic, he rules out every day. But then, on Wednesday, he's taken by surprise. This paradox blends logic with psychology, showing how expectation itself can backfire. The Heap Paradox. Sorite's Paradox. In a desert village, a child begins removing grains from a heap of sand. At what point is it no longer a heap? 1 grain? 10? 50? The paradox shows how vague definitions can blur boundaries. When does a bald man become bald? Or a pile become not a pile? Our language struggles to handle subtle shades of meaning and ambiguity. Zeno's Arrow Paradox. Picture an archer who shoots an arrow. If you freeze time, at every moment, the arrow is motionless in space. If it's at rest at each instant, how is it moving? Zeno challenges the notion of motion itself, suggesting that change is an illusion. But we know arrows fly, so what's really happening between the still frames of time? The Twin Paradox. 2 twins. One stays on Earth, the other rockets into space at near light speed. When the traveler returns, they're younger. Time has bent. This paradox from Einstein's theory of relativity shows how motion affects time, a fact proven by astronauts and atomic clocks. The Bootstrap Paradox. A historian finds a time machine and goes back to give Shakespeare his own plays. William Shakespeare becomes famous. Centuries later, the historian learns the plays from history books. So, who actually wrote them? This paradox questions the origin of information in time loops. The lottery paradox. You believe that each ticket in a million-ticket lottery will lose, but you also believe one ticket must win. You accept each belief individually, but they can't all be true together. This paradox shows how collective reasoning can break down. The paradox of value, diamond water paradox. Why are diamonds expensive, but water, essential for life, often cheap? This paradox, observed by Adam Smith, highlights the difference between utility and scarcity. Economics solved it through marginal utility. We pay more for what's rare, not what's vital. The Crocodile Paradox. A crocodile steals a child and promises to return it if the parent guesses correctly what it will do. The parent says, "You won't return the child." Now, if the croc returns the child, the parent was wrong. But if it doesn't, then the parent was right. Either way, contradiction reigns. The paradox of the court. A law student agrees to pay his teacher after winning his first case. The teacher sues him for payment before he's won any. If the teacher wins, he should be paid. But that means the student has now won. If he loses, the student doesn't owe. It's a legal riddle with no clean resolution. Russell's Paradox. In a library, some catalogs list themselves, some don't. So imagine a catalog that lists all catalogs that don't list themselves. Does it list itself? If it does, it shouldn't. If it doesn't, it should. Russell's Paradox shattered early set theory and forced a rethink of mathematical foundations. The two envelopes. Paradox. You're given two envelopes, one with twice the money of the other. You pick one. Then you're told you can switch. Should you? The math seems to say yes, always. But if everyone switches, something's wrong. The paradox lies in misleading expectation, the paradox of choice. Imagine choosing a jam at the store. Dozens of flavors? Sounds good. Yet studies show more options make us less satisfied. This paradox reveals how too much freedom can freeze decision-making and fuel regret. Sometimes less really is more. Grelling-Nelson Paradox. Imagine you're playing a game with adjectives. Some describe themselves, like short is a short word, others don't. Like long isn't long. Now ask, does the word heterological, meaning not self-descriptive, describe itself? If it does, then it doesn't. But if it doesn't, then it does. This loop traps language in a logical twist, where the definition eats its own tail. Epimenides Paradox. In ancient Crete, a philosopher named Epimenides, a Cretan himself, claimed, all Cretans are liars, but if he's telling the truth, then he must be lying. And if he's lying, then maybe he's telling the truth? This ancient version of the liar paradox shows how self-reference can unravel the meaning of truth altogether. Pinocchio Paradox. Picture Pinocchio saying, "My nose will grow now." If it does, he's telling the truth, but then his nose shouldn't grow. If it doesn't, he's lying, so it should grow. The result? A wooden boy with a truth so twisted, even his magical nose gets confused. Curry's Paradox. Suppose someone tells you, if this statement is true, then 2 plus 2 equals 5. Now, if the statement is true, then 2 plus 2 must equal 5, which is false. But if the statement is false, then the condition doesn't matter, and it loops again. Curry's paradox shows how self-reference can break logic in subtle, alarming ways. Predestination Paradox. Imagine a man travels back in time to stop a disaster, only to accidentally cause it. His actions, meant to prevent fate, become the very reason fate occurs. In this twist of time, free will dances with destiny, making you wonder, are we ever truly in control? Newcomb's Paradox. You face two boxes. One is transparent with $1,000. The other is sealed and may have $1 million or nothing. A super-intelligent predictor has already guessed your choice. Take both or just the sealed box. If you trust the predictor, you should take one. But if you want to be greedy, you might lose big. It's a clash between reason, belief, and prediction. Olbers Paradox. Look up at the night sky. It's dark. But if the universe is infinite and full of stars, Every direction should end at a star. The sky should be blazing. So why is it dark? This paradox sparked questions about the age and structure of the universe, leading to discoveries about cosmic expansion and the Big Bang. Maxwell's Demon Paradox. In a lab, imagine a tiny demon guarding a door between two gas chambers. It lets fast molecules through one way and slow ones the other, seemingly creating order from chaos, breaking the laws of thermodynamics. But the demon isn't magic. It represents the limits of knowledge, measurement, and how observing the universe affects it. Schrödinger's cat paradox. You place a cat in a box with a quantum device. Until you open the box, the cat is both alive and dead, a ghost in two states. This isn't about cats, really. It's about quantum physics and how particles exist in multiple states until observed. The cat? Just a furry metaphor for the weirdest rules of reality. The Gibbs Paradox. Imagine you have two identical containers of air. You remove the divider between them. Nothing changes, right? But classical physics says that the entropy, or disorder, should increase, even though the gases were identical. Why does mixing two of the same thing count as new disorder? This is the Gibbs Paradox, which asks, can you really call it mixing if nothing's actually different? The Twin Earth Paradox. Imagine a planet just like Earth in every way, except what they call water isn't H2O. It's a different chemical that looks and behaves exactly the same. On Earth, we say water is H2O, but on Twin Earth, it's not. So when someone there says water, are they talking about the same thing as we are? This is Putnam's Twin Earth Paradox, and it challenges our assumptions about meaning, reference, and language. The Monty Problem. You're on a game show. 3 doors. Behind one, a car. Behind the others, goats. You pick door 1. The host, who knows what's behind the doors, opens door 3, revealing a goat. Want to switch to door 2? He asks. Most people say it doesn't matter, but switching gives you a 2/3 chance of winning, not 1/2. This is the Monty Problem, and it shows how our intuition about probability can deceive us. The Birthday Paradox. You're in a room with 22 other people. What are the odds that 2 of you share a birthday? Most guess low, maybe 5 or 10%. But in reality, it's over 50%. With just 23 people, it's more likely than not that someone shares a birthday. This is the Birthday Paradox, where probability and human intuition clash. The Banach Tarski Paradox. Imagine taking a ball, breaking it into pieces, and somehow reassembling those pieces into 2 identical balls. Same size, same shape. No stretching, no adding matter. Just duplicating mass. Sounds like magic? It's not. It's the Banach-Tarski paradox, a mind-blowing result from pure mathematics that defies physical reality. The prisoner's dilemma. 2 suspects are arrested and interrogated separately. If both stay silent, they get 1 year in jail. If one betrays and the other stays silent, the betrayer walks free, and the silent one gets 3 years. If both betray, they get 2 years each. Logic says, betray. But if both do, they end up worse off. This is the prisoner's dilemma, showing how individual rational choices can lead to collective failure. The Trolley Problem. A trolley is hurtling toward 5 people. You can pull a lever to divert it onto another track, where it will kill one. Do you pull it? Now imagine, same situation, but this time you must push someone off a bridge to stop the trolley. Why does the method change our moral judgment? This is the Trolley Problem, a classic ethical dilemma that tests the boundaries of right and wrong. Buridan's ass. A donkey stands exactly between 2 identical piles of hay. Unable to choose, it starves to death. This is Buridan's ass, a paradox of perfect symmetry. It questions free will, decision-making, and what happens when no option stands out. The Moral Luck Paradox. 2 people drive home drunk. One hits a pedestrian, the other doesn't. One goes to jail, the other sleeps peacefully. But both made the same reckless choice. So why is one condemned and the other not? This is the Moral Luck Paradox, where outcomes, not intentions, shape our moral judgments. The brain in a vat. You wake up one day and ask, how do I know I'm not just a brain in a jar, being fed fake experiences by a computer? It feels real, but can you prove it is? This is the brain in a Vat thought experiment, a modern twist on Descartes' skepticism and a cornerstone of simulated reality theory. The Preface Paradox. When confidence meets doubt. Imagine you're an author. After years of research, sweat, and sleepless nights, you've finally finished your masterpiece. A 500-page book on the mysteries of the cosmos. Every page is footnoted, every claim backed by data. You believe in what you wrote, but in the preface, you write something that every honest author does. Despite my efforts, there may be errors in this book. Now here's the twist. If you believe each statement in your book is true, how can you also believe there's an error in it? Welcome to the Preface Paradox, where logic and humility collide. This paradox reveals a strange quirk of belief. You can believe something is true, while also believing that not all your beliefs are true. It's like saying, I'm sure I locked the door, but I might be wrong. The Preface Paradox doesn't make you irrational, it makes you human. It's a reminder that even in confidence, there's room for caution. And maybe, just maybe, that's wisdom. Galileo's Paradox. When infinity plays tricks. Galileo Galilei, the father of modern science, was fascinated not just by the stars, but by numbers. One day, he considered this. Every whole number, 1, 2, 3, has a perfect square, 1, 4, 9, 9 dots, and every square is matched to a whole number. So it seems like there are just as many squares as there are whole numbers. But wait, most numbers aren't squares. There's 2, 3, 5, 6, 7. They go on forever. Doesn't that mean there are more whole numbers than square numbers? Yet Galileo saw something strange. Both sets are infinite, and they match up 1 to 1. So how can a part be equal to the whole? This is Galileo's paradox, and it opened the door to the mind-bending nature of infinity. In the world of the infinite, a part can equal the whole, and our everyday logic just doesn't apply. It's like a hallway with infinite doors. Somehow every room is filled, and there's always room for more. Welcome to the strange universe where math, like space, has no end. The Abilene Paradox. When everyone agrees to be miserable. It's a sweltering summer day in Texas. A family sits on the porch sipping iced tea. Someone says, "Hey, why don't we drive to Abilene for dinner?" No one really wants to go. It's 50 miles away, it's dusty, and the food isn't even that good. But nobody wants to ruin the plan or seem disagreeable. So they all say, "Sure, let's go." They drive, sweat, eat bad food, and drive back in silence. When they get home, one of them finally says, "I actually didn't want to go." The others chime in, "Wait, me neither." This is the Abilene Paradox, when people go along with something they don't want, thinking everyone else does. In reality, nobody wants it. It happens in families, businesses, even politics. Everyone nods, but no one agrees. And the result, bad decisions based on imaginary consensus. The Abilene Paradox teaches us something powerful. Speaking your truth, even when it's uncomfortable, can save everyone a long, hot drive to nowhere. The Black Hole Information Paradox, a story of cosmic secrets. Imagine a spaceship, not just any spaceship, but one carrying the universe's most embarrassing secrets, lost love letters, failed math tests, bad karaoke videos. Now imagine hurling that ship straight into a black hole, gone, erased, swallowed by gravity's ultimate monster. Or is it? That's the mystery that shook the smartest minds on Earth. According to Einstein, anything that falls into a black hole is gone forever, sucked past the point of no return, the event horizon, never to escape. But here's the twist. In the world of quantum mechanics, information is never truly destroyed. It can change form, scramble, even hide. But it must always be preserved. And now you have two of the universe's biggest theories in a cosmic fistfight. Einstein says black holes delete information. Quantum physics says they absolutely cannot. This is the Black Hole Information Paradox, a conflict at the heart of physics. So what happens to the spaceship's secrets? Do they vanish forever into the black abyss? Or are they encoded somehow on the surface of the black hole like a hologram, flattened and burned into the cosmic firewall? Even Stephen Hawking wrestled with this. In his later years, He proposed that black holes might leak information back out through faint radiation, now famously called Hawking radiation. But if that's true, then black holes are no longer cosmic shredders. They're slow-motion escape rooms for the truth. To this day, no one fully knows the answer. What we do know is this: the universe is watching, remembering, even when it looks like it's forgetting. And somewhere out there, floating in the dark, might be a black hole humming with stories, waiting to be decoded.